All right, so this is 7.2, part 2. So I just want to go back over 8 and just talk about it. Okay. So yesterday we were talking about it. It said no, what was it? No denominator, right? So they didn't want like a denominator. There's another thing that they sometimes post with it, Leah. They want like a kind of like for you to rationalize your denominator. All right. So let me explain to you what that means. So yesterday when we were kind of working through number 8, okay, we reversed that and like flipped it up and we got x to the 1/3 over y to the 7/3, right? Okay. And then we couldn't do anything with the numerator, so we just left that. But the denominator, notice we could do something to it. 3 goes into 7 2 times. And that's why I can't have my things. And then we had 1 left over. Are you okay with me there, Leah? Yeah, and that's where I'm getting to. Okay. So here we have this. All right. And we kind of, yesterday we just said, okay, we can't have a denominator because Hansi was giving me a hard time. So we just wrote y to the negative 7/3, right? But I want to talk about what does it mean when we rationalize a denominator. All right. So basically what I'm going to do is I'm going to take it one step further than yesterday. All right. And I'm going to kind of start here. All right. So I'm going to start here, Hansi. Okay. So I went one step further than yesterday. Now, Leah said, can I write this as a radical? And the answer is yeah. And that's what I'm going to do.
What is a radical?
That.
What is special about that?
It's just what it's called. Okay.
But like what makes it a radical?
It's just an operation. Like multiplication will make something multiplication. Okay. So we need to rationalize this part because we can't have square roots in the denominator. Okay. Now, do you guys remember from like algebra when you had something like, or geometry, when you had like, let's just say 5 over root 2? Do you guys remember that? How you would deal with that? How to rationalize it? Anybody? Not divide, but multiply. So we would rationalize it by multiplying by root 2 over root 2, okay? And this would give me 5 root 2 over 2, all right? So we're going to kind of do that here. But this is kind of tricky, okay? So we have a cube root in the denominator. So what do I have to multiply there to kind of make it go away? Now, Leah, this is why, like here, this can be like tricky. So this is what you wrote, right? Okay. And you can see we have a radical in the denominator. Agreed? All right. So let me backtrack to here because this is where you want to be. You want to feel comfortable here. All right. And here's why. To make this kind of like, I guess the appropriate term is like kosher or like cool or whatnot. What we want to do is we want to make this whole, y to the 1/3. So in order to rationalize this, what I'm going to do, and this is going to seem strange, but is I'm going to multiply by y to the 2/3. Now, Leah, do you see why I multiply by 2/3? Y to the 2/3? Okay. I multiply by 2/3, Leah, because this y to the 1/3 and the y to the 2/3 are going to pair up. Right? Do you see that? 1/3 and 2/3, 3/3. That's y. So this will become, when I rationalize the denominator, x to the 1/3, y to the 2/3 over, right? these two together combine to give me 1 and a y squared. So that's going to be x to the 1/3, y to the 2/3 over y cubed. All right. So there's a couple things going on here. One, I don't think you have any on your web assignment, but you might have one of those on the SATs where it asks you to say, hey, rationalize the denominator. And you have something that's like, you know, y to the 1/3, okay, in the denominator. But for this, what we were doing yesterday, what we did, Hansi, that was fine, okay, because we made it not have a denominator. So I just wanted to kind of go a little further today because we were talking about it and expose you to how do I rationalize the denominator with a, you know, radical that's not a square root. Hansi.
Did you get a haircut?
No. My hair just falls out occasionally and then it kind of like starts over. No, I did. Yeah, I gotta cut it the ultimate shave. That's my plug going on my YouTube channel. Okay, in Glen Mills. Okay, shout out. Maybe like my whole 2 followers, maybe one person will go there. Also got the beard cut. Get asked for passes in the hallway now. You know, got that baby face. You see it? The baby face. When I go to the movies, they're like, sir, can we see your ID? I'm like, listen, I'm like 36. Thank you, I appreciate it. All right. Do you really think I look, you know, 16? So I know, that's why I get, yeah. You look older than me now. Crazy. No, you, Nikki Grantland. You, Nikki Grantland. Look older than me. It's crazy. Jake's like staring into my soul. So, all right, let's go to the next one. All right, here, pretty simple and straightforward. Okay, we're going to rotate those up. So it's going to be g to the 2/5, h to the 7/5. Okay, since no denominator, I could rewrite it that way. Let's work on rationalizing the denominator. So I'm going to have g to the 2/5. 5 goes into 7 one time. And I'm left with h to the 2/5. All right, so for me to rationalize the denominator, I'm going to want to make this whole. So I'm going to multiply the top and bottom by h to the 3/5. Because that will make 2/5, 3/5, 5/5. That gives me g to the 2/5 times h to the 3/5 over 1. And then I have the h out front, so it'd be h squared. All right. Do you guys see where I got that from? Jake.
Kind of, but like, how did we get the 2/5 and 3/5 at the top? Like, how did you set
Here. All right. Do you see how I got that?
Yeah.
That came from that. 5 went into 7 one time. There's that h. 2/5 was left over. How do I make 2/5 whole? 3/5.
Oh, okay.
Okay, and I can do that because this is 1. H to the 3/5 over h to the 3/5 is 1. I didn't change anything.
And you didn't do anything else with g.
Yeah. This rotated up. X to the 8/4, y to the 11/4 over z to the 6/4. 8/4 is 2. Okay, y, I'm not really going to mess around with that. I could, but I'm not going to. In the denominator, I have z. Okay. Then I'm going to think hard about this. I have 2 as a remainder, right? 2 as a remainder. Agreed? 2 out of 4 is 1/2. So this is z to the 1/2. So I'm going to multiply by z to the 1/2 over z to the 1/2. My answer would be x squared times y to the 11th force, v to the 1/2, all over z squared. Not too bad, right? The bottom, z, and that's 1. All right. The only thing I can think about with this problem is the Key and Peele sketch. So, makes me laugh. You guys watch Key and Peele? You guys gotta watch Key and Peele. They're hilarious. All right. So we have a hypotenuse here. All right. Yeah. So I'm looking for this diagonal length. So I have 6 and 9. Does anybody remember how to do this?
You multiply them by half.
Nope.
You
Nope.
if they all equal to a certain.
Nope. Do you know? Which is? Very good. A squared plus b squared equals c squared.
Why are we going back here?
Kaylin, which one is A, B, and C? And that's all you need to know, because it doesn't matter A or B. So I'm going to write 9 squared plus 6 squared equals c squared. 9 squared is 81. 6 squared is 36. C squared, we're going to find. 81 plus 36 is what, 117? Take the square root of both sides. Since we're talking about a length, I don't have to talk about the negative version of this. All right, what's the square root of 117? All right, what number is going to 117?
1.
And 3. How do you know 3 goes in? 1 plus 1 plus 7 is 9. 3 goes into 9. So this is 3. Not quite. 3 times 1 is 117. I believe that's 39. 3 goes into 39 3 times. So C equals 3 root 13. That's it. All right. Any questions? All right. Cody, what did you want to work on? Sure.